Hi guys, this is my hackathon demo. It's called Reproduction of Dreamer Reinforcement Learning Algorithm. So it's a reinforcement learning algorithm. And here he is. Here we go. So what this is here we zoom in a bit. As you can see, it's controlling a little half cheetah robot and getting him to walk forward, really slowly. So this is trained using reinforcement learning and deep learning. So what's going on here is this little robot's receiving some sensor inputs, which are sort of joint tensions and stuff like this, and he's using those inputs to generate some outputs, which is making him walk forward. So and this is done using obviously deep learning and reinforcement learning or AI algorithms. Quick look at the architecture, how this works. And so, there's really three sort of steps here in the training process. The first step, we run the loop, which takes in data from the sensors, runs it through this policy, which is a neural network, and then that outputs actions into the environment, which is how hard it should turn its motors, what forces it should apply on the body, on the robot. And then the physics environment then computes the next frame, and this process repeats, and that drives the robot forward. And so the trick is to come up with this policy. And so the way that's done is it's a two-stage process. That's something that's unique about this algorithm. In the first stage, it learns a differentiable dynamics model, which is effectively a physics model that sort of predicts how the robot body is going to work, and that what that basically does is take in the states, take in the actions, the motor forces, and then computes, hey, what's going to happen next. And then the whole reinforcement learning loop is trained using this learned differentiable dynamics model. And so what happens there is you run the policy on, you start at some initial state, you run the policy on the model. The model tells you what's going to happen next, and then you have your reward function and your value function to figure out how good your actions are. You blend those together, and then this training process just repeats and repeats and repeats, ultimately changing the weights and updating the weights in this little policy here. And then once that's done, you drop that back on the environment, run it for a bit, see how it goes, and then take more data from the environment and just repeat this whole process. And so there, and that's the end result. This trained on my just little computer here with just a couple of graphics cards, and it took no more than a couple of hours to get this guy into this sort of state, where he's able to do some very sort of rudimentary walking behaviors. Cool. Okay, thanks guys.